Morning, viewers. Welcome to MouShauk, and a very happy and prosperous new year to all of my viewers. So let's start with a new chapter in physics of class 9 syllabus. Okay, so it's a pressure in fluids and atmospheric pressure. Okay, so let's start with that. And so before that, I will request you to please do subscribe my channel if you have not subscribed yet. And if you are a new viewer to my channel, then please do subscribe the channel and ring the notification bell, because that will notify you as soon as a new video is uploaded. And if you are liking the video, press the like button, share with your friends so that they can also be benefited from this video. And do meditate before you start your day. And so for meditation, let us concentrate on a point of light. Okay. So just for 1 minute, let us concentrate for on a point of light. Think that light is falling on you and you are enlightened. And you're feeling energetic, feeling blessed, you're happy, you're doing your job very happily and quickly, completing it on time, getting appreciation. Always think positive in every aspect of life. And at the end of the day, thanking God for always being with you and giving you such beautiful moments in your life. Thank you. Okay, so let's get back to our work. That is, let us start our discussion. That is pressure in fluids and atmospheric pressure. Okay. So first, we are starting with thrust and pressure. First topic which we are starting today is thrust and pressure. So what is thrust? Thrust is the force which is acting perpendicularly on an object. If this is the object and a force is acting like this, that is acting just perpendicular to the object. Okay, so that is called the thrust. Okay, it's a vector quantity because it has a direction. Okay, its SI unit is Newton and its CGS unit is dyne. So 1 Newton is equal to 10 to the power 5 dyne. Okay, the gravitational unit is in MKS is kgf. Okay, kilogram force, and in CGS it is gram force. And the relation is 1 kgf is equal to 9.8 Newton and 1 gram force is 980 dyne. Okay, so thrust exerted by a body, that is equal to weight of the body. Okay, so any object which is placed on a body, say if a book is placed on the table, okay, so the weight of the book will be the thrust on the table. Clear? So that is thrust exerted by a body will be weight of the body. Okay. Now it is the same in whatsoever position the body is placed on the surface. Okay. Whatever the position may be, it is on the surface, the value will be the same. Okay, so the pressure is the force or the thrust acting. Then we have completed the thrust. Now we come to the pressure. So what is pressure? Pressure is the force or thrust which is acting perpendicularly on a unit area of the object. Okay, on unit area of an object, like say area of an object is say 1 centimeter square. If it is of a say the surface is a square shaped, okay, and all the sides are 1 centimeter. So the object's area will be 1 centimeter square. Now on this 1 centimeter square, the amount of force or thrust which is acting perpendicularly on this object of 1 centimeter square, that is known as pressure. Thrust is equal to, therefore, pressure into area. Or you can say pressure is equal to thrust by area. Okay. So according to the definition, pressure is equal to thrust by area. Thrust or force by area. Okay. It is a scalar quantity because it has no direction. The same force which is acting on the smaller area exerts a larger pressure, and on a larger area exerts a smaller pressure. So if two objects have been taken, okay, having same force, okay, which same force is acting on both the objects, but one object has a smaller area and the other object has a larger area. So this is small, this is large. Same force is acting, okay. The pressure will be on this smaller object will be larger, and on this larger area object, the pressure will be smaller. Okay, same force, but due to the area, this is small area, this is larger area. Okay, so if this is smaller area, as this is a smaller area, the pressure will be large. As this is a larger area, the pressure will be small. Clear? The SI unit of pressure is Newton per meter square. See from the formula, pressure is equal to force by area. So force, thrust or force, same thing. So force's unit is, or thrust's unit is Newton. So Newton per meter square, and it can also be named as Pascal, PA. Okay, 1 Pascal is the pressure exerted on a surface of area 1 meter square by a force of 1 Newton acting normally on it. Okay, so 1 Pascal is equal to 1 Newton by 1 meter square. CGS unit is dyne per centimeter square. 1 dyne per centimeter square is equal to 0.1 Newton per meter square, or 1 Newton per meter square, or that is equal to 10 dyne per centimeter square. If thrust is equal to 1 gram force and area is equal to 1 centimeter square, then 1 gram force is equal to 1 gram force per centimeter square. Okay. Then other units. So the pressure will be, pressure will be 1 GF by 1 GF per centimeter square. Okay. So there's some mistake here. So please rectify that. Other units is equal to bar and millibar. 1 bar is equal to 10 to the power 5 Newton per meter square, and 1 millibar is equal to 10 to the power minus 3 bar, or you can say 10 to the 10 square Newton per meter square. Okay. 10 square Newton per meter square. Okay. So the continuation of the same topic, the atmospheric pressure is generally expressed in terms of height of mercury. Okay. See, the pressure can also be atmospheric pressure also. So that it can be expressed in terms of heights of mercury, that is the barometer. The normal temperature and pressure, the barometric height is 0.76 meters of Hg and 76 centimeters of Hg and 760 millimeter of Hg at sea level, taken as 1 atmospheric pressure. The atmospheric pressure is also expressed in terms of unit atmosphere. Okay. So 1 atmosphere is equal to 0.6 meter of Hg, that is equal to 1.013 into 10 to the power 5 pascals. Okay, so pressure can also be used as atmospheric pressure. So atmospheric pressure, it is measured in Hg, mercury, height of mercury. Okay. So that is equal to, you can see the one barometric height. It can be a barometric column. In the barometric column, it is measured. And the one barometric height is 0.6 meters of Hg, or 76 centimeter of Hg, or 760 millimeter of Hg at sea level, which is taken at 1 atmospheric pressure. And 1 atmospheric pressure, that is equal to 0.6 meters of Hg, 1.013 into the power 5 Pascal. And sometimes torr is measured. So torr is named after Torricelli. Torricelli was a scientist. After him, that torr has been mentioned. So unit of pressure, that is. So 1 torr is equal to 1 millimeter of Hg, or 1 atmosphere, 1 atm is equal to 760 torr. Okay. So let's move on to the next topic, that is factors which affect the pressure. Two factors are there which affects the pressure, that is the area on which the thrust is applied and the magnitude of thrust. How much force is applied and what is the area on which the force is applied. Okay. So there's some example. First example is the pressure which is exerted on by a brick. Okay. See, one brick is placed in this way. Okay. And this is the vertical position. It has been kept, and the other brick is kept in the horizontal position. That is here the surface area, which is coming in contact with the surface, that is less. And in this, the surface area is more. Okay. So, but both the weight of the same brick is same. Okay, so that is 100 Newton. So that 100 Newton is what? That is the force, that is the thrust. Not her. Yes, that is the thrust. That is the same. Force is same. Only the area is different. Here we can see the surface area, it is 0.1 meter square. And in this case, in the standing position, it is 0.01 meter square. Here, so the pressure changes. Okay. So in first position, the pressure becomes 1000 pascals. And in the standing position, second position, the pressure becomes 10,000 pascals. So a stretch brick which is kept on the ground exerts less pressure, okay, than a brick which is kept on the ground in the standing position. So what happens here? See, you can see that the brick which has been placed in the ground in the stretched way, that will exert a less pressure than a brick which is present in the standing position, that will exert a more pressure. Because the surface area which is in contact of the brick, its stretched position is more comparison to the brick which is in the standing position. Therefore, we know that as pressure increases with the decrease in surface, so therefore we can see that when the surface decreases, pressure increases. When the surface becomes large, the pressure will decrease. Okay. So this is the example of the pressure. Another example is one brick is kept another one. Okay. That is one above the other is kept like this way. Okay. Like this. One brick, then another brick is kept like this. But both of them are identical, same weight, same size, everything is same. Okay. Now what happens? The thrust becomes double. Same weight kept one above the other. So what will happen? The thrust will become double. Okay. But the area will be the same. Okay. So what will happen? The pressure on the ground gets doubled. Okay. Why? Because if the thrust of the first brick is say 100 Newton and the second brick which is also 100 Newton, so the thrust becomes what? 100 plus 100, that is 200 Newton. Base area remains, that is 0.1 meter square. Okay. So the pressure on the ground becomes what? 200 by 0.1. That means 2000 pascals. So we can see, so if in the first case, see here, if we keep in the first picture, if we keep another brick just above the other, then what will happen? This pressure will become 2000. Here it's 1000, that will become 2000. Okay. So that is the thing that has happened, that the pressure will get doubled if the thrust is doubled. Okay. Hence, larger the thrust acting on the given area, greater will be the pressure exerted. Okay. Now, ways of to increase the pressure. How will we increase the pressure? These are some of the ways you can increase the pressure. See, if a sharp knife, if you take a sharp knife, which has a very thin surface area, very small surface area. Okay, so more effective, it will be more effective than a blunt knife, because the blunt knife, the surface area will be a little bit more than the sharp knife. So the sharp knife will have less surface area than the blunt knife. So the sharp knife will have more pressure than the blunt knife. The blunt knife will have less pressure. Okay, because due to the surface area. Same pressure, same force you are acting on it, you are giving on them. Then a nail, which is a pointed edge, will require less force. Okay, it will be easily, it can be nailed on the wall. Why? Because with the same thrust which you are applying, which you are a limited thrust which you want to apply, that will be enough for that pointed nail to go inside the wall, because the pressure will be more. But if you if you take a blunt nail, then if you will have to exert more pressure, more force on it, because the blunt that nail which has a blunt end, that will have to exert that will require more pressure to go inside the wall. Okay. Now, tip of the sewing needle. If the tip of the sewing needle has to be very thin, very pointed. Okay, that will work faster. Then edge of an arrow, here also the edge of an arrow will have to be very narrow. Then edges of the tool used for piercing things, that will also be very pointed edge, it has to be. So we can give less force and more pressure will be applied on it. With less force, more pressure will be applied on it, and the work will be very easy. Okay. So from these ways, we can say that for a given thrust, the pressure on the surface is increased by reducing the area. If we reduce the area, we can increase the pressure. Okay. Then ways to decrease the pressure. If you want to decrease the pressure, what we will do? We will increase the surface. Like in the railway tracks, wooden sleepers are placed. No, wide wooden sleepers are placed, so that the pressure which is exerted on the railway tracks, that becomes less. Okay, on the ground that becomes less. Okay. Then the tires of the buses and the trucks that are broad enough, right? And double wheels are there, so that the pressure on the tires, that is less. Okay, the surface area is increased, so that less pressure is applied on the tires, and the tires do not burst. Okay, and they can carry heavy weights. Okay, then the foundation of the high-rise buildings that are kept wide. Why? Because the less pressure is applied on the ground, and the building will not sink into the ground. Okay, so from this we can say that for the given thrust, the pressure on the surface is reduced by increasing the surface area. Okay, so let us stop here. I will start with the pressure in fluids. Okay. So till then, to give a look to this, what we have studied now till now, and also the previous chapters of this class, also in the other classes which I have completed. If you have any doubt, please do write in the comment box. Do share with your friends so that they can also be benefited from these videos. And do subscribe my channel if you have not subscribed yet, and please ring the notification bell so that as soon as the new video is uploaded, you will be soon notified. Okay. And don't forget to meditate before you start your day. Okay. So thank you. Bye bye. And have a nice year. Okay.